Welcome. My name is Greg Marcoux. I'm one of the assistant directors of admission here at Rensselaer. Thank you for joining us on this Tuesday evening. It's Tuesday, right? Yes, on this Tuesday evening to learn about the Electrical and Computer Systems Engineering Department here at Rensselaer. We have two wonderful staff members from the department. We have Rama, who works in the student services side of the department, and then we have Dr. John Wen, who is the professor, or the department head for Electrical and Computer Systems Engineering. So they'll be presenting to you today. If you have any questions, feel free to throw them in the chat. I do have a little welcome message there for you, so feel free to throw them in the chat. We will answer them throughout the presentation and at the end. So at this point, I will pass it off to Rama and Dr. Wen.
Welcome to the webinar from the Electrical Computer and Systems Engineering at Rensselaer. There are more people joining. That's terrific. So it's a beautiful fall afternoon here in Troy, New York. Hope you're staying healthy and safe where you are. I remember many years ago, many decades ago, when I was looking at colleges and thinking about major. At that time, I remember I wanted to be an engineer, but I didn't know much about any particular disciplines of engineer. My dad was a mechanical engineer, so I know I don't want to be a mechanical engineer, but I didn't know, what other engineering was about. So I wish I had a webinar like this to learn more about a particular discipline. So use the chat box to ask questions. Feel free to interrupt. We are very much acclimated to this online environment because we do right now, but this semester, we do our teaching, we use the online tools quite a bit, which may continue, most likely will continue for a little while. We use the chat box quite a bit to ask questions, answer questions, and interact. So feel free to interrupt if you have any question. So what I will address today, hopefully, is to address the question you may have, is that since you sign on, you must have an interest in electrical, computer, and system engineering. But what is electrical and computer and system engineering? So I'll give you a very brief introduction at a high level of what this discipline is about. We'll talk a little bit about what you will learn, within this discipline in your 4 years of college. And after you graduate, where you might work and where do our graduates work. And now, all of you are in high school. What could you do to prepare for a career in electrical, computer, and system engineering? And so you're probably seniors. It's next fall is not that far away. So what would the first year of electrical, computer, system engineering will be like? And hopefully by that time we'll be on campus instead of doing this anything remotely. Okay, so fingers crossed. So first of all, what is electrical, computer, and systems engineering? That's quite a mouthful. So when you talk about electrical engineering, you will think about electricity. Maybe you think about power. Right now we had a storm here. Was it last week that knocked out the power, and you immediately realize how important electricity is, right? With all the food in the fridge and with the internet, I had to teach a class using my cell phone's data and watching those precious data running down. But electrical engineering and computer and system engineering is much more than that. Of course, electricity is very important, and power systems and power transmission, power distribution, renewable energy, all of those are very important. But electrical engineering is actually pervasive. So let's just take the smartphone. I talked about using my smartphone to teach a course. Smartphone is a quintessential example about the importance and the contribution of the discipline. So starting with the central processing unit, but not just the, so we all know about semiconductor and microprocessor, VLSI, very large scale integrated circuits. etc. But it's more than just the hardware you see, but it's also a lot of the software, such as the user interface. From the hardware aspect, the touch screen, how does your finger actually generate a signal to tell the computer what to do? And I use Siri, and some of you use Google Voice, Google. I forgot what the name is. The voice command interface. So there's a lot strong software component. That's where computer part come in, and then systems engineering is where all the components will fit together into a cohesive whole with not just individual components, starting from the CPU and the keyboard, etc. But now you want to tie everything together, like conducting a symphony, working in unison, and that's where the systems engineering come in, from the networking, from the storage, from computation, from the sensing, from localization, from user interface, from the security. All of those fall within our umbrella of electrical computer assisted engineering. So we have a big tent, and necessarily we work with many other engineering disciplines and many other disciplines in in general to combine our technology to make an impact to the application. So another area that you may more associate with perhaps biomedical engineering or medicine is in healthcare. Of course, that's we all want to put a stop, to put a kibosh on the COVID-19, and so we. As a discipline, contribute a lot in that area, from lighting, deep UV, that's the ultraviolet, that can serve as a function of disinfections. Our faculty actually invented a device to, in a high throughput fashion, very efficiently disinfect masks. And to the sensing and diagnostics using our sensor and signal processing, to instrumentation, to more system level tools such as modeling to look at how COVID-19 spread. So we have faculty actually contributing in that direction, to medical imaging, and to something that's close and dear to my heart is robotics. That's my field, and the robotics is using many different ways, from the clinical care to care for patients in the intensive care units, to delivery of food and medicine, to sanitation, to disinfect, maybe using deep UV, and to help with socialization, like what we're doing now. And instead of having a fixed computer, you can have a robot following you around and serve. You can almost have a avatar, a conduit, a mobile conduit for communication. So all of this fall within our umbrella. So we have a very big and diverse field, and it also offers a way for you to really pursue your particular interest and passion that we can typically find a program for you. Electrical engineering has a long history. It started in about 150 years ago, and starting with James Clerk Maxwell, and he developed Maxwell's equation to describe electromagnetism. And then ever since then, there's been huge explosion of inventions from communication, like telephone, from power, from lighting through Edison, and from the to generation of power, such as motor, to converting electrical energy into the mechanical energy, and the transmission of power. So there are some big names, Edison, Tesla, and Westinghouse, you might have heard, and they play very big role here. And then, of course, for communication coming into being with electromagnetic waves, such as radio and then television, and computation start coming into the scene to instead of doing pen and pencil or using mechanical computer, we can do things much faster and much more compactly using digital computer starting in 1930s. And then comes the semiconductor revolution of the transistors, integrated circuits. And here is where some Rensselaer graduates really contributed to the advance of the fields from the invention of microprocessor. Tad Hoff was one of the inventors, to digital cameras. Steve Sasson at Kodak received his bachelor and master degree from RPI, from our department, to a power semiconductor, or IGBT, which is used to convert a DC power to drive for high power applications. And then, of course, the internet. With the email, Ray Tomlinson was credited for the invention of email. And now that comes to your generation. Actually, my generation is a personal computer, and your generation is smartphone. And increasingly, the smartphones become smarter and smarter. Not just the phone, but all the devices around us. So the advance of the Internet of Things, or even your light bulb is becoming smart. Your thermostat is becoming smart. And now with the ubiquitous presence of sensors, how do you harness all this data to infer, to learn about the environment, to learn about human behavior, and to try to anticipate or try to predict the human needs? That's the artificial intelligence and machine learning. And we're deploying this at bigger scale, at the building scale, even city scale. And of course, now not just things that we use to communicate, but we also have physical presence, such as robots. And together with all of this, we also open up ourselves up to vulnerability, to attacks, like ransomware, to cyber attacks. So the cybersecurity is also becoming increasingly important. Not only that we want to utilize all these tools, but also we want to use all these tools in a secure way. So for you guys, that you will be the class of 2025 now. So the question is, what will you be working on? What would you contribute? And what would you invent, to really have fun? So that's where you can, use the 4 years in your college to really blossom, learn new things, and grow, and contribute to the society. So ECSE as a field, I talked about a lot of the foundational stuff, which is the electronics, power, communication, networking, and my field is in control, information, imaging, etc., semiconductors. So you will learn about all those foundational disciplines, and this has, as I mentioned, a long history, and a lot of work has been done. So you will learn all those foundation and draw on those to apply to applications maybe we can only dream about. So for a very complex system, human automation interaction, artificial intelligence, etc., and increasingly space. So that we maybe you read about that SpaceX is really eyeing Mars. Blue Origin is eyeing Moon. So that will be truly the next frontier, and electrical engineers has a big role to play to enable that we can do this in a safe and effective and productive way, and really transforming human lives. So where do our students go? A lot of our students go on graduate school. They continue to get a higher degree. and master PhD. A lot of them go to various companies, large companies such as IBM, Raytheon, ABB, and a lot of them go to startup. One of my graduates just got a new job offer as a startup in Boston, and so they're in robotics area. And some of our students working in iRobot. I have students working in Corning, students working in government research labs such as JPL, which I was at for a while. So there are lots of opportunity, and electrical, computer, and system engineers are highly sought after because you have when you graduate, you will have a deep fundamental understanding. There's a firm foundation as well as exposure to various application areas. So you can. So maybe you didn't learn a particular specific aspect of what a company works on, but your training will allow you to adapt what you've learned to quickly tailor it to the needs of your job. So it's a terrific discipline, lots of opportunities, and you can also use this as a springboard to branch off into other areas. A lot of our graduates become entrepreneurs, start their own companies. Sometimes they get a business degree as well, like MBA, and they become CEOs of the company, CTOs of the company. So there are lots of paths forward in addition to being engineers, scientists, and researchers. And some do become professors like me, which is also a terrific career. So we have 30-some faculty, so we're a fairly large, we're one of the largest department and one of the oldest department in Rensselaer. And in terms of students, we're also one of the largest, if not the largest. I think we're the second largest in terms of student enrollment. We have over 800 undergraduate students in 2 curricula, which I'll talk a little bit about. We have a master's program, but we have a very robust and large PhD program for advanced research. What we emphasize is also a lot of the faculty will take on undergraduate students to help in the research program. So the undergraduates, and even you as undergraduate, freshman, sophomore, may have a chance to work with more advanced PhD students and professors to engage in research. Now, so one question you may be asking, say, okay, this all sounds well and good, but would I really fit well in ECSE? Does the culture of ECSE fit with me? Here are just some of the hints, some of the suggestions to you to see whether ECSE may be a good fit. I asked myself that question when I was a student, and certainly, if you have this curiosity of how things work, how the cell phone work, how the quantum computer work, etc. When you read about something about the detection of COVID, or the CT scan now can not just do imaging but will help diagnosing whether you have cancer. So you're curious, how does that work? That curiosity is an innate attribute of a ECSE student, but not just to know how it works, but you also have a passion you want to make things, a pile of components to make things come together, work as a system, and make it work better. So we have, for example, working on the electric aircraft, to smart building, electric car, renewable energy. So you also have a drive to not just to learn how they work, but also to make them work and work better. Then you will also fit very well. And finally, our students also have a drive to want to create new things, from the little things such as circuits and chips and the components, to put them together as a sensor, and to do at the system level as algorithm, such as robots, and that's my robot in my lab. Then all these are the attributes of ECSE students. However, I did mention that we have two curricula. One's electrical engineering and one's computer system engineering. So which one should you choose? Does it really matter? In the start, maybe you can wait and see which one that will really draw on, bring out your passion. But I just want to provide some general guideline. Basically, these two programs, both are under our department, are very similar, very close, and they both provide essential fundamentals for you to operate as an electrical engineer, or as a computer engineer, or as a system engineer. The difference between these two curricula is that electrical engineering has a slightly more emphasis of physical system, physical device, and systems. I understand more towards maybe microelectronics, power systems, power system device, machinery, transmission, etc., versus computer system engineering, which has a little bit more software and algorithm component. But the difference is not huge, and we should see decurriculating a bit. But both will provide some fundamentals in electrical, computer, and system engineering. Again, electrical engineering is a little bit more physical, computer and system engineering a little bit more algorithm and software. You might have read about a dual major, that it's possible to have two majors, and the advantage is that you could double count the courses, the requirements that are overlapping between the two curricula. So especially if you have AP credits, a dual major is a real possibility. So when should you consider dual major? Okay, so let's say you have passion for multiple subject matter. You really like electrical engineering or computer engineering, but you also like physics. You really like to understand how systems work at a physical level. You want to learn more about quantum mechanics. And then how do you pursue both curricula at the same time? You may have a passion more for software engineering and computer science and algorithm. You want to go in greater depth. So maybe you want to do engineering and computer science. So all these are possible, but what are the trade-offs? The trade-off is that you will need to forego the free electives. So right now, there are a number of courses you can do whatever you want. You can pick up, African drumming. You can pursue your interest in music, or learn a new language. Really beef up your language skills. You can typically use your free elective towards that. So now the free elective will be taken up by the other major. And it's challenging because you may have two majors which are both challenging STEM area, science, technology, engineering, and math type of area, and you will need to work extra hard. That would take up not just your free elective, but your free time as well. But it may be worth it, especially if you're ahead of the schedule. But this is by no means necessary if you feel that, maybe I would give out some of my free time and this will give me an advantage in the future. I don't think that's necessarily the compelling argument. It's better to really do very well in one area, in one major, and then have general exposure to the others, rather than getting just so burned out with a dual major. So you do have to weigh the pros and cons. Another possibility, if you want to pursue a separate interest, is minor. And this typically, when it's very difficult to combine two curricula. For example, you want to do something economics, cognitive science, very hard to do major, but you can still do a minor in that area and major in electrical engineering. Okay, so these are some of the decisions you have to make. You don't have to make this right away. You will have a couple of years, the first couple of years, the engineering curricula are all somewhat similar. So you still have a chance to change your mind or pursue something a little different, within the first couple of years. In terms of the courses, you can see the overlap between the two curricula between electrical engineering and computer system engineering is quite a bit. There's a bunch of core courses, the introduction to electrical engineering, circuits, electronics, etc. And there are a bunch of courses which are more specific, which are required for electrical engineering, a bunch of courses which are required for computer system engineering. So if you look at the courses that for electrical engineering, again, it's more physical system oriented, and then computer system engineering is more algorithm and software oriented. Okay, so in addition to all these engineering courses, of course, you have other computer science and math, core requirement, and you have humanity. You want to be a well-rounded citizen of the world. So humanity and social science core requirement. There's core engineering courses that's required for all engineering students. And finally, there are a bunch of design courses from introduction to engineering design to capstone design that will integrate all your learning into a challenging, large-scale, team-based projects. Okay, so now what will your first year be like? For electrical engineering and computer system engineering, the template is a little bit different. So for our incoming, freshmen this year, so for you'll be for 2021, you'll be exposed to electrical engineering right away. Okay, through this course, Introduction to Electrical, Computer and System Engineering, Intro to ECSE. So whether you're EE or CSE, right away you will get this introduction. And this course is very interesting. Not only you will get some hands-on experience to learn about electrical, computer, and system engineering, but you also there's also a seminar component. You will hear about research and grand challenge problems that ECSE faculty and so we'll also have external speakers. The ECSE practitioners will come into class and talk about what they work on and the impact to society. And then you have other, the core requirement, computer science, math, the humanities and social science. And then in the spring semester, you will get also a discipline-specific course. For electrical engineering, you get something called embedded control. This is more using a microcontroller to control something. It could be a self-driving car, it could be a blimp, it could be a drone, but it's using a microcontroller. Learn to do the C programming, basic programming, and learn the basic control, feedback control. And for computer system engineer, you will take computer component operations to learn about what really goes into a computer. What are the different major components that make a computer working as a system, and as well as other core requirement courses. And for this ECSE 1010, Intro to ECSE, this is really a gateway course to the discipline. And starting from this year, of course, this will apply to you as well. Every incoming ECSE student will get this kit. Basically, this is a personalized data acquisition board, and this is very timely kind of addition to our curriculum, especially within the midst of pandemic, that you can do your own experiment. You can get a kit that goes with the personalized data acquisition, and you use your own computer as a driver for this. You can and the storage. You can use this tool to learn and conduct labs and work with others, and then to learn the basic concept of about the electrical engineering, computer, and systems engineering. And for this is actually based on the donation of one of our alumni. He was one of the early employee of Analog Device, and now he is retired. He has done very well, and he is retired, and he shared part of his wealth with us to help you to get a jump start of your career. And then when you go on to the junior and senior year, you have a whole bunch of electives. How do you choose those electives? Those are called restricted and technical, electives. We want our students to use those electives in a focus area based on your interest and passion. So this will help you not just have the breadth of the foundation, the breadth of knowledge and training. You also have the specific tools and knowledge in a particular area of your choosing. So right now we have 10 structured elective, structured concentration area from electronics, photonics, to robotics, AI, etc. So they involve, a few required courses and a few elective courses, and you can use your technical elective and your restricted elective to build up a background and training in one of these concentration. Now, suppose you have your own passion. You say, I'm really interested in medical device. I want to learn about medical technology, how electrical engineering is used, used towards medical, in the medical field. You can actually design your own concentration together with your advisor. So the program is meant to be very flexible, tailored to your passion and interests. In terms of our faculties, research, we encourage our students to participate in undergraduate research program. Our faculty engage in stuffs which are very broad, from networking to information science, signal processing, and to my field, control and autonomy. We have faculty doing computer system design, doing the VLSI design, the electronics and photonics, and people who are involved in power system, energy and power system. So there are lots of research opportunities available, and our faculty are very research active. They're funded by research grants, and some of those can be used to support undergraduate students to get involved. We also have some new program we just started this year. I will ask Rama to talk about them. Rama really put this two program together to provide additional dimension to our undergraduate curriculum. Rama?
Yeah, hi everyone. So we have a couple of really great programs to get you kind of more connected to the ECSC community at large. So our biggest one is our Industry Advisor program, which connects our current students with alumni for one-on-one industry advising. So you'll really get to see what the different options are, what you can do with your ECSC degree, and hear from someone who's been in the same place that you are. And our alumni are so excited about this program. And it's been really great. And there's also some panels with our alumni. Again, we really want to show you what's out there, give you all the support you need. And we also have kind of other outreach with our alumni so that you can make connections in your field and again, see what the many, many possibilities are. We also have an undergraduate graduate mentor program for students who are interested in going to graduate school. So in junior or senior year, you get paired with a graduate student, and they can help you prepare, kind of start the process. What are you looking for? How do you find somewhere that's right for you? How do you find an advisor that's right for you? Just someone who's really been in your situation pretty recently, advising you on kind of the next steps. That's also a really great way to meet people within our ECSC community and make great connections. So we've got a lot going on to connect you with students who are at RPI right now, and also alumni and the sort of greater RPI community that's been built through ECSC.
So let me just go back a little bit more. Another thing that Rama put together is a forum, like a chat forum. It's called part of WebEx team for the entire department, and with a bunch of subgroups to allow people to pursue a specific interest. Rama, you want to talk a little bit about that? That's for the entire department, so you can interact with students in all years, not just in your cohort.
Yeah, and it's a great space. Our faculty are on it as well, and all of our staff advisors, so people like me. And it's a great place to ask questions. Students use it to connect with other students in their class, students outside of their class, to make study groups. It's just a really great place to also get questions answered. And right now has really been helping us build a community while everyone is, or some people are not on campus, things are remote. So we're just, kind of making sure to keep
Yeah,
our
thank you
students
very much,
connected with
Rama.
each other and with
So
UCSC.
you may be asking yourself, wow, this all sounds very exciting. Can I do anything before I come to college? What should I do, to get a jump on things? So I would recommend, doing some reading there to get better acquainted with the history of electrical engineering and somebody from its history to its development to its latest challenge and advance. So we have a recommended reading list, and some are for fun, like The Martian, Ready Player One, with a strong engineering component embedded in the fiction, and there are other more nonfiction, but still very interesting to read to learn about the history. I would recommend that you to beef up math and physics. That's always useful. Math, even things not just calculus, but probability, linear algebra, all those things. More the preparation, the better. And programming. We do a lot of programming, being electrical, computer, and systems engineering. We do a lot of programming. So you will learn Python here, but Python is free. It comes with, chances are it comes with your computer. You can download it. And there are a lot of packages on there to do all sorts of things. So I would recommend that if you probably know this already, but if you don't, get a jump on it to learn Python programming just for fun. As a fun exercise is to do Python turtle, to write a Python program to make the turtle do interesting things, maybe to have multiple turtles interacting, or to create a remote access turtle, to create a computer program. So one of my students actually did a Space Invader. You guys were too young to remember the game Space Invader, but it's a bunch of a Space Invader coming down the screen, and you have to shoot them down. And he created something called a space turtle invader. So there are a bunch of turtles start coming down, and then you have to ride around to shoot them down. Again, he wrote this whole thing using Python, using the Python turtle package as a starting point. Now, if you're interested in robotics, like in my field, there's also a lot of open source stuff that's free, for you to download, and with the whole community chipping in to help you learn. So I would recommend you learn robot operating system and learn how to use GitHub, to download other people's code, and also to share your own code. So there are some links here so since this video will be available, you can certainly look at those links. The links are, for the ROS tutorial and the GitHub tutorial. And there are also ROS books. These are all free online. It's such a different world than when I was a student. When I was a student, we used punch cards. Can you believe it? Anyway, so now all this stuff is free for you to take. Now, finally, for you to decide which school to pursue, whether you want to go to a large public school or smaller private school like us, whether you want to go far away from home, across the country, that's a lot of decision. So the best way to make a decision is to find out more about a place. And also, again, based on my experience, is you want to find a place that's compatible with you culturally. In terms of personality, it has the right match with your your personality and approach. I went through 4 different colleges in Canada, 2 in Canada and 2 in the United States. So from very large public college to small private college, such as RPI. And I really like RPI's culture. The working closely with industry, and the emphasis on rigor and the emphasis on problem solving, and understand what are the real needs, and really making an impact. So the best way to learn is to talk to people who are already here. So we have a page that have a number of videos to meet our students. If you want to learn more directly from them or talk with them, you can always go through Rama to make appointments to actually do a one-on-one interaction with our students or faculty. And finally, connect with us through Twitter, LinkedIn, Facebook, or just our webpage. And if you have any question, feel free to reach out to me or to Rama, our undergraduate student coordinator, and we can connect you with other faculty or the students depending on your interests and questions. So I'll stop here and see if you have any questions that I can answer.
Yeah, Dr. Wan, I'm not seeing any questions coming into the chat, but I know there's one, and I believe there's a student here who I spoke with yesterday who's really interested in robotics. I told him that you're the robotics guy. So I don't know if people, I'm sure many of the students in this webinar are interested in robotics. I was wondering if you could talk a little bit about Rensselaer and how robotics works.
That's right. Yeah, we do have a robotics concentration. So I teach robotics. So we have, and robotics is a very broad field. Includes machine learning, includes computer vision, includes control system, mechatronics. So all those courses together makes the field, constitute robotics. So it's a very integrative field, and so that we have courses that fit together within the concentration to train you in robotics. We also have a lot of robotics research that we're engaging with the industry companies to solve real robotics problem and to really meet the needs. So I have lots of undergraduate students from all disciplines, from electrical engineering, from computer science, from mechanical engineering, working together to tackle problems. So some of those problems are on the YouTube channel. So it's on the link right now. It's a Control Guy 168. Control Guy is already taken. So it's a Control Guy 168. I don't see any. Do we have any? We don't have any students from China, but so 168 in Chinese actually means something, sounds like something. Anyway, that's why I chose it. Anyway, so take a look at the YouTube channel, and you will see some of my projects. Some are very industrial oriented projects. Some are for my courses. Some are related to assisted robots of how do you get robots to help perhaps severely handicapped, like quadriplegic individuals who are very cognitively sound but are physically challenged. How do you use robots as avatar, as a surrogate to help the individual with daily living? So there are some videos along that line as well. But certainly, if you have any questions, reach out to me, and I'll be happy to tell you more.
I think Greg is frozen.
Greg, even though he is sitting very still, or frozen, yeah. Yes, he is frozen. Yeah. In any case, feel free to reach out. I know it's a lot of decisions to make, but good luck to you. It's a fun time to get ready for a big decision, a big step in your life.
Yeah, we also have 2 other admissions ECSE webinars coming up. There's one next week that's on our
Great.
Intro to ECSE class, so you'll get more of an idea of what you cover in that class. And then in November, we have one for a higher level, a 4,000 level computer vision course. So you can learn a little bit more about, kind of what you could be doing as you are a little bit further in your degree. So you get a really good chance with both webinars to see kind of what's offered in 2 of our classes and what are some things you can do with
Fantastic.
ECSE.
Yeah, that's great. Okay, so if there's no question, then have a great evening. Okay, yeah, so we'll sign off now. Okay, how do I sign off?